Welcome to Sundar's lecture. This is lecture number 100, and in this lecture we are going to see some numerical problems related to 2 watt meter method, right? So what are all the topics we have seen in the previous class? See, we have started with the power measurement actually. We have started with the power measurement. There are 3 different methods are available. 3-phase power measurement, 1 watt meter method, and we have told that this watt meter reach only real power, which means it is V phase, I phase, and then it will be cos theta, cos pi, that angle between V and I, right? So that value will be read by this wattmeter, right? Only real power. And we can also find what is the reactive power from this reading. That I will explain you a bit later, right? So next one, we have seen that 3 watt meter method, directly we can get the answers, but 2 watt meter method, this is very important, right? 2 watt meters can be connected in 3-phase circuit to measure the 3-phase power, and how that works we have proved it, right here you see we have proved it, right? So we have taken an example, we have connected like this, and we have drawn the phasor diagrams, and then we found what is V1, and then we found what is V2, everything we done, right? Everything we have already found, right? W1 and W2. With the W1 and W2, if you add these two, you will get what? Real power, this one, this is real power. And see here, if you minus W1 and W2, subtract and multiply with root 3, you will get a Q, that is reactive power, right? That is also we found, right? We found. And now today we will go for problem. See, what is the problem they have given you? Phase sequence ABC. They have given phase sequence ABC, source voltage 100 volts. So source voltage in sense what? It is whatever they have given you, that is nothing but this line voltage, that is 100 volt, right? Then 58 system, obtain W1. We need to find what is the value of W1, right? See this one, you try to understand. This is star connection, right? So in star connection, V phase will be is equal to 100 divided by root 3. This we know, right? V phase, that is the phase voltage, right? Next one, we need to find W1, right? So how will you find W1? See, W1 will be is equal to W1 where it is connected A phase and then B phase. So it will be VAB, line voltage, and line current, that is IA, that is IA, and cos of this angle we need to find. This angle we need to find, right? So if we know, right, what is VA? What is VAB? Sorry, what is VAB? It is VA minus VB, right? This is the value. And now you try to understand, we need to find the IA value, and with some angles we need to go. I will go for that. First we find what is the phase current. What is phase current? It is V phase divided by Z. What is Z they have given you? It is 10 plus J 2 ohms. Then obviously maybe I will go for the modulus of phase current. So modulus of phase current, it is 100 divided by root 3 multiplication of this value 10 plus 2j, right? Modulus value. Try to understand. You have to get the modulus value. And if I go for this one, I am getting I phase is equal to 5.66 amperes. 5.66 amperes. And the another thing, if you convert this Z into, this is in rectangular form, this one you convert this one into polar form, you will get Z will be is equal to 10.19. If I convert this one, 10.19 at an angle of this value, I am getting it to be 11.31 degree ohms. Right now you see, this is the angle, right? This is the power factor angle. And you see this one, if I am getting this one is 11.31, then obviously if I'm going for I phase, then the modulus of I phase is 5.66 at an angle of, this one will be minus 11.31 degree amperes, right? Why? Because this one comes in the division. I is equal to V divided by Z, right? So this one will come like this because we I will explain you, right? If I'm going to draw the phasor diagram, anyway I'm going to draw the phasor diagram. We will assume VA, that means phase voltage, as the reference. Phase voltage VA, that means this is phase voltage, right? So this one is VA. This is nothing but VA. And if this is VA, then this is balanced circuit. That is why, see here, Z, everything is balanced. So you will get this one will be VB. That means ABC sequence. So A comes first, B comes next, and then C, right? This one, this is now VC, right? Try to understand one thing now. Now see here, this is the phase voltage, this is the phase current, right? This is the phase voltage, and this lags by 11.3 degrees. So IA, where IA will come, since this is balanced circuit, see, IA will come here like this. This is IA with a magnitude of 5.66 and minus 11.31 degrees. So this angle, this angle, this angle will be 11.31 degree, right? Next one, we need to find VAB. Since we have to find the angle between these two, and we have to put here, right? So what is VAB? Already I have VA, and I need to find what is minus VB. See here, it is, I will take another color. See this one now. So this one will be minus VB, and if you add these two, what you will get? What you will get? What you will get? This is nothing but VAB, and this angle is 60 degree, and what happens to this angle? Now this will be 30 degree, right? We have found. Now you see what is the angle between VAB and IA. That is what we need here, right? VAB and IA. What is this one? Between this one, 30 plus 11.31. So this will be 30 degree plus 11.31 degree. So what will be the W1 value now? So W1 will be is equal to, what is VAB? That means this is a the line voltage is 100 here, 100 into phase current, line current and phase current are equal in the star connected system. So this value, it is 5.66 multiplication of cos of 30 degree plus 11.31 degree. So if I simplify this one, so I am getting W1 will be is equal to 425.15 watts. 425.15 watts. This is the value I am getting. See, try to understand certain things, right? You have to draw this phasor diagram. Then it will be easy. Right? So where between any two lines you connect this wattmeter, and you just draw this diagram. It will be very simple, right? Don't mug up any formula. See, I have just derived this formula, right? Here, this one. See this one. W1 is equal to VL cos of 30 degree minus pi. See, this is not a formula. Try to understand. So many students make mistake here. This is not a formula. This is applicable only when the wattmeter is connected between R and B. And the wattmeter 2, where it is connected between Y and B. See, try to understand. This is a procedure. That how this wattmeter will read. And you should not apply this formula for all the connections. Try to understand. So students makes mistake here. That is why I am punching here. See, you just get the values. You just draw the diagram like this, and you try to find the values with the phasor diagram. Wherever you go, you draw the phasor diagram. now we have drawn many a times these phasor diagrams. We have drawn many times, right? So you are now very good in drawing the phasor diagrams, right? If you follow my lectures, I always prefer to draw this phasor diagram, right? Okay, fine. We will go to the next one now. And now you see the same question. Find W1 with ABC sequence they have given you. It is 100 volt 50 hertz. See here, the same question, but this is changed, interchanged. This is C and this is B now. And now what happens? What happens to W1 now? The same thing. So I will go fast now. It is VL is equal to 100 volt. Same star connected system. So obviously then V phase is equal to 100 divided by root 3 volt, and then if you are going to find what is W1, see formula will vary here. What is W1 now? W1 will be is equal to VA and C, right? VAC now. This will come as VAC. Between A and then C, the wattmeter is connected, and this current is same, IA, right? This will be IA, and we need to find what is the cos angle. And obviously you see here, if VAC will be is equal to what? It is VA minus VC, and okay, fine. Now we have done this one, and simply you just go find what is the value of I phase, and that is also very easy, right? What is I phase? This is 100 divided by root 3. Same question, you go for the modulus value, and this will be 10 plus 2j. If you take this one, it will be 10.19. Anyhow, this I phase is will be same here, 5.66 amperes. And then if you are converting this Z into the polar form, it will be 10.19 at an angle of minus 11.31. Everything is same here. Everything is same. Right. Now we need to find and we need to get what is the IA value. IA will be is equal to 10.19. That means I phase, not IA anyhow, not IA. I phase. I will write it as I phase, so that you can easily understand. I will tell you. This one will be minus 11.31 degree amperes. And if you are drawing the phasor diagram, see, I will go for the phasor diagram because we need a different value here, right? Between IA, VAC and IA, we need to find what is the angle, right? So now you see this one, same. Here also it is VA is the reference. VA is the reference. Don't confuse with this. So this one, which is nothing but this is VA, and if this is an ABC sequence, they have given you it is ABC sequence. So it will come like this, maybe bit larger. See, I don't have any graphs here. I don't have graphs, so it is length will be equal. Lengths will be equal. So you try to understand, right? So this value, this will be VC. And you see here, I need IA, same as usual, same. So if I need IA, then simply this one. This will be IA, and what is this angle? This angle will be 11.31 degree. And you see now, I need VA is already here. I need VC here. VC, try to understand. Minus VC, right? Minus VC. So this one, you just project in this way. This is nothing but minus VC, and we need to add VA and VC. So this will be your VAC. See this one, this angle, this angle is total angle is 60, and this angle will be what? 30 degree, right? And we need to find what is this angle. Right? Between VAC and IA. This is IA and this is VAC, right? I need to find what is the angle between these two now. So you know, see, angle between VAC and IA I need to find, right? So what will you get here? See here, this is total of 30 degree. This is total of 30 degree. That 30 degree from here to here minus this 11.31. Try to understand. So try to understand 30 degree fully, and you have to minus this angle so that you will get this one. So this will be 30 degree minus 11.31 degree. So simply what you do now, you put here, this is 30 degree minus 11.31 degree. Simple, right? Can you understand? So what we will do now, W1 will be is equal to VAC. Again, this is line voltage. This will be 100. This is 100. Multiplication of this value maybe phase or line current, both are same. 5.66 multiplication of cos of 30 degree minus 11.31 degree. And if I simplify this, I am getting it to be 536. 536.15 watts. 15 watts. So see, this is the final answer. See, one thing you have to be very clear here too. See this one. Both the circuits are same, but this wattmeter is connected in a different way. You should not conclude that the power will vary. No. It is not like that. If you find what is W2 here, find W2 and add two answers. Add W1 and W2, you will get a real power value. And what you do here, you find again W2 for this circuit and you add W1 and W2, you will get the real power. Both real powers will be same. Try to understand. You can connect your wattmeter in any lines between A and B or A and C, whatever it may be. You just change it down, but the wattmeter reading will be a different one. But the real power will be, see, P will be is equal to W1 plus W2. This value cannot be changed, right? Unless the Z values are a different one, voltages are a different one. Try to understand. Don't conclude like that. Don't conclude, right? So I've just taken this example to differentiate what happens if the wattmeter connected in the different lines, between different lines. That is why I have taken this example, and you don't conclude that this is the final answer for of real power. No, it is not like that. Anyhow, so we will move on to the next one. We have to go very fast now. See, what is the question they have given you? A 415 volt three phase supply is connected to a three phase balanced load. They have given you three phase balanced load, 415 volts. So what you do, you just write it down. VL will be is equal to 415 volt, right? And then what is now V phase? Obviously this is star connected system. V phase will be is equal to 415 divided by root 3. I have to write this one straight away, right? Straight away. And then draws 20 amperes current at a 0.8 power factor lagging. See, I will be is equal to, that means I will be is equal to 20 amperes, and then power factor, which means they have given you cos pi is equal to 0.8. This one they have given you in lagging, right? That is the question, right? Phase sequence is RYB phase sequence. This one I have written here RYB. Two wattmeters are connected for three phase power measurement. Two wattmeters, they have shown you only single wattmeter here because they are going to ask you what is the value of W1. They have not shown you W2, so don't think that there is no W2. It is there, it is there. Right, two wattmeters are connected to measure the power. The first wattmeter current terminals are connected, so they are just telling which terminals. It is R, and the voltage terminal is connected between R and Y. Current terminal is connected here through R, and voltage terminal is between R and then Y, right? What will be the reading of the first wattmeter? That is the first question. See, first question, we need to find W1 is equal to what? That is the question. If the load changes to 20 ampere with 0.8 leading, what will be the reading of the first one? See, try to understand. We will go for the second one afterwards because this one is lagging now and this is now leading. Anyhow, we need to find what is the pi value. What is the cos pi they have given you? It is 0.8, right? Then from here, if you are going to find what is the pi value, then it will be 36.87, right? 36.87 degree, and we know that one. So if this one maybe the current value, if it is lagging, current value is lagging, that they have given you, right? So I will be is equal to what now? It is 20 at an angle of minus 36.87 degree, right? This is the current value. Why? Because this is lagging. This is lagging. Straight away they have given you, right? So what you do now, we need to find, see, wattmeter is connected between, so wattmeter, I will write the formula here anyhow. See, if I write the formula, what I will get here, between RY, right? So V R Y and then this is connected in IR, and then cos of some angle. I need to find, right? So again, I will take R as the reference phase. Maybe I will write here. I don't have space. R as the reference phase. R has the reference phase. That means the phase. Phase angle, right? So now I will draw here. See this one. R. This is nothing but I am taking it to be VR. RYB sequence they have given you. So I will go a little bit fast because you are well trained for drawing the phasor diagrams, right? This is Y, and you take this is now B, right? You try to understand. I need to find what is IR, right? IR. How will you find IR? See, this is lagging, right? This is lagging from VR. This is nothing but phase, right? This is phase actually. Generally, it is phase, and you have to draw it for VR, VB. Everything it may be same, right? The same angle. It lacks that 36.87. B it lacks 36.87. If you are going for IB, IY, I am going for IR, right? This is 20. This is 20. This is 20 amperes, and this angle lagging. See, lagging, that is why I'm drawing here. If it is leading, then I would have drawn here. You have to understand those kind of things, right? 36.87 degree. And what we need, the another one, see what is VRY. I have already told you. I'm just writing it down. What is VRY? It is VR minus VY. These kind of things we have done so many things, so many times. So already it is VR is here, and what you need to do, you have to go for minus VY. This is nothing but minus Vy, and if you are drawing this one, simply this is Vry, and this is 60 degree, and what is this angle? This angle will be 30 degree, and what is the angle between Vry and then this is IR, right? This is IR. What is the angle between Vry and IR? 30 plus 36.87. So this value will be 30 degree plus 36.87 degree. Simply, so what will you get here? I will draw here, right here. So W1 will be is equal to what is VRY phase line voltage, that is 415 multiplication of what is this phase current or line current, both are equal, magnitude value 20 multiplication of cos of 30 degree plus 36.87 degree. Simply, right? What will you get now? If I simplify this, W1 will be, so I am getting it to be W1 is equal to 3260.39 watts. So see here, this is the watt meter number 1 reading, right? And now you have to see what is the second question. If the load is changed to 20 ampere with 0.8 leading now, 0.8 leading, what will be the reading of the first wattmeter? That is the next question, right? I will take it to the next page. See here, I will just write it down. I is equal to 20 amperes, right? At leading angle. At what is the leading angle? It is cos pi is equal to 0.8. That is they have given you. And simply if you get what is pi value, it is 36.87 degree. Anyhow, this value will be what? Plus 36.87 degree amperes, right? And same VL will be is equal to 415 volt. Those kind of things also will be same. There is no difference. But what is now W? W1 will be same again. It is connected in the same phases between two lines, same line. So same formula will come. VRY. It is IR. And then cos of, you need to find this angle. Why? What happens to this angle now? So anyhow, I will draw the phasor diagram. I will draw here because I have more space. See this one. This is now VR. Same RYB sequence. They have not changed anything, right? They have just told you that this angle, this current is leading now. That is the only difference. So this will be VY, and if I am going like this, and this will be VRYB, right? This is VB, and you see now this current is leading, right? Leading. So if it is leading, then what happens now? That means by 36.87 degree, 36.87 degree. So this angle will be like this. maybe the value of current is less, right? So in this angle, this is now IR, this is now IR, and what is this value now? What is this value? I will write here. This is 36.87 degree. And you see now, this I have found this one. And we need to get what is the value of VRY. We know, right? VRY is equal to VR minus VY. And I have VR already. VY I need to draw, right? VY. You just draw like this. So see this one. This is minus Vy, and if you add these two, right, if you add these two, it may come like this. This is nothing but I am calling it to be Vry. And what is the angle between these two now? These two. This is 30 degree. Am I right or wrong? This is 30 degree, right? This is 30 degree, right? What you have to find now? You have to find what is the angle between Vry and then IR. What will be the angle? See, this is 36.87 degree and this is now 30 degree. So 36.87 minus 30 degree, right? So you see simply the angle, that means VRY, and then IR, you try to understand. This is totally 36.87 and from that this 30 has to be subtracted. So 36.87 degree minus 30 degree simply. So what I can do here, I can put this one as 36.87 degree minus 30 degree. That is the answer. That is the final angle. So W1 will be is equal to what is VRY? Again it is 415. That is given. Multiplication of IR, it is 20. Multiplication of cos of 36.87 degree minus 30 degree. So if you simplify this, so I am getting it to be W1 will be is equal to 8240.41 watts. See here, this is the final answer. See how much it makes a difference, right? It is 8240 here, it is to 3260 if it is lagging per factor, and if it is leading, the wattmeter 1 reads this much of watts, right? So my point is very clear, and I want to make you very clear now. You don't panic if they have given you any questions like this. Try to get the knowledge, try to write the equations, and from that you draw the phasor diagram. Draw the phasor diagram. If you draw the phasor diagram, then there will not be any confusion, right? Don't mug up any formulas. You W1 will be is equal to IL, VL, multiplication of cos of 30 degree minus pi, 30 degree plus pi. Don't mug up anything, right? So what are all the topics we have seen today? See, we have taken with the problems related to 2 wattmeter method, and we have taken like this, right? It is connected between A, B, wattmeter number 1, and we found what is W1 value. And in the next one, in the next case, we have taken this is C, and we have found what is the value of W1 again. And then we have gone for this problem. They have given you two conditions. One is a lagging power factor and one is leading power factor, right? So what we have done, we have just drawn the phasor diagrams like this. This is the phasor diagram where we need to find the angle between VRY and IR, and we found like this. We have drawn this one for the lagging power factor, and we found what is W1. And here you see we have gone for the lagging power factor, leading power factor, right? So current leads here, and again we have drawn this diagram and we have found what is the value of W1, right? So you go through this. We will take another two problems in the next lecture, right? Thank you. We will see in the next lecture.